Good morning, my dear students. Our chapter number 11 is going on, which is ray optics. In this chapter, the topic is going on, which is lenses. Okay. Yesterday, we learned power of lenses and lens maker formula. This is very important topic. So carefully remember it, students. Okay. Today, we learn combination of thin lenses. So we discuss about our new topic, which is combination of thin lenses. Firstly, we take two lenses, and after that we take more than two lenses. Okay, suppose we have two lenses L1 and L2. Both are convex lenses. Okay, suppose this is the first convex lens L1 and this is another convex lens L2. So suppose we have two lenses L1 and L2, okay, are placed in contact. This is L1 and this L2. This is these are coaxial. So this is the principal axis of both lenses. Their focal lengths are f1 and f2 respectively, and optical center O1 and O2. Clear it? Now, suppose we have an object which is placed at O point, this object O, on a principal axis. Firstly, we consider here L2 is absent. Means in the absence of L2, the image of object, for image of object, two rays emitted from this object. First is passing through the optical center and second is incident on any point. Okay, after the reflection, these rays are meet at a point I, and at this point this is I dash, and at this point I dash, image is formed of this object by the refraction of L1. Okay, these are rays. Okay, but this image I dash acts as a virtual object for this L2. Object for this lens L2. Then by the refraction due to this lens L2, image is formed I of this object I dash. So we can say the final image of the object O is I. Okay, which is by the refraction of L1 and L2. Clear it? Now we write lens formula for L1. In the absence of L2, we write lens formula for L1. For this is the distance of a object from optical center, means U, and this is the distance of a image for L1, this is V dash. Clear? So lens formula we know that 1 upon beam distance, 1 upon image distance minus 1 upon object distance is equals to 1 upon focal length of the lens. So for L1, for lens L1, lens formula 1 upon V dash is the distance of image minus 1 upon U, distance of object, is equals to 1 upon F1. This is equation number 1. Okay, here we take very thin lenses, so we can consider O1 I dash this O1 I dash approx equals to O2 I dash. Because of these are a very thin lenses, so optical centers of these lenses is placed very near. Okay, and this I dash acts as a virtual object for the lens L2. So in this situation, for lens L2, distance of a object is v dash, and a distance of this image is suppose v. So 1 upon v minus 1 upon v dash is equals to 1 upon f2. This equation number 2. Here we combined both lenses. So from equation, on adding equation 1 and 2, then we get 1 upon v dash minus 1 upon u plus 1 upon v minus 1 upon v dash is equals to 1 upon f1 plus 1 upon f2. This term cancel out to this term, then we get 1 upon v minus 1 upon u is equals to 1 upon f1 plus 1 upon f2. This equation number 3. So in the combination of lenses, we get this equation. Okay. Now we consider a thin lens of f focal length is located in place of both lenses. Okay, means these lenses replaced by a thin lens which focal length is small f. Then in this situation, distance of object is u, and distance of final image is v. Then in this situation, lens formula is 1 upon v minus 1 upon u is equals to 1 upon f. This is equation number 4. Now comparing equation 3 and 4, then we get 1 upon f is equals to 1 upon f1 plus 1 upon f2. Okay, clear it. This is the effective inverse of a effective focal length of combinations of a lenses. This equation number 5. Okay, now if the many thin lenses of focal length f1, f2, f3, f4 and so on are placed in contact. Okay, so in this situation, effective focal length 1 upon f is equals to 1 upon, according to this equation, 1 upon f1 plus 1 upon f2 plus 1 upon f3 plus and so on. Okay, this is the effective effective focal length of a combination of lenses. Here we can say the reciprocal of effective focal length is equal to the sum of a reciprocals of a focal lengths of a lenses. Okay, we know that power of lens P is equals to 1 upon f. So from this equation, the power of combination of lenses 1 upon f is equals to P is equals to 1 upon f1, means P1 plus P2 plus P3 and so on Pn. So here we can say the total power of a combination of lenses is equal to the sum of power of each lens. Sum of power of each lens. Clear it? Okay students, now magnification. This is focal length and this is power. इस इक्वेशन से अपने कहा कि पावर जो है वो जितने भी लेंसेस थे उन सभी की टोटल पावर के ऐड के इक्वल होगा. सिमिलरली हियर मैग्निफिकेशन. What is the magnification? Magnification is the ratio of a height of image to the height of a object. Okay. Here we can say the image formed by first lens. The image formed by first lens work as a object for second lens. Okay, and similarly the image formed by second lens work as image for third lens. Okay, this indicates that the total magnification is the product of individual magnifications produced by the lenses. So, okay, so from this phenomena, we can write m is equals to total magnification of combination of lens is equals to m1 multiply m2 multiply m3 and so on. Okay, from this equation we can say the total magnification of this combination is the product of individual magnification produced by the lenses. Okay students, this phenomena, this type of combination is used for cameras, a telescope and other optical instruments. Okay, so this is the topic is combination of the lens. So our next topic, this is image formation by lenses. So our next topic is image formation by lens. Okay, for making the image by thin lenses, which is can maybe convex or a concave, the rays diagram is traced according to some rules. Okay, so first rule is rays emerging from the object. Okay, from when rays incident parallel to principal axis. Suppose this is principal axis of the convex lens. Okay, when rays incident parallel to the principal axis, after refraction, the lens, this ray pass through second focus point. Suppose this is a second focus point f2, this is first focus point f1, this optical center O. Then after the refraction, this ray pass through second focus point, or for concave lens appear to come from a first focus point. Means this is concave lens, this is principal axis. Suppose this ray incident on parallel to principal axis. After the refraction, the way of this ray is this. So this ray appears to come from the first focus point f1. Okay students, this is first law. Means कोई भी रे जब प्रिंसिपल एक्सिस के पैरेलल इंसिडेंट होगी, देन इस कंडीशन में या तो वह सेकेंड फोकस पॉइंट से पासिंग करेगी, अदरवाइज ऐसा फील होगा, ऐसा वर्चुअली लगेगा कि जो रिफ्लेक्टेड वेव है वो फर्स्ट फोकस पॉइंट से आ रही है. क्लियर हुआ फर्स्ट law. Second law is when the ray passing from first focus point, this is convex lens, this O, and this is f1, this f2. So the ray passing from first focus point like this. After the refraction, this ray go parallel to principal axis in this way. Clear it? Or the ray appears to be coming towards first focus point, then after the refraction go parallel to principal axis. Means यदि जो लाइट रे है वो फर्स्ट फोकस पॉइंट से इंसिडेंट हो रही है, इससे पास करके इस लेंस पे इंसिडेंट हो रही है, देन आफ्टर द रिफ्रैक्शन यह प्रिंसिपल एक्सिस के पैरेलल हो जाएगी. क्लियर है? थर्ड पॉइंट, if the ray passing through optical center, then this ray emerges from the lens without any deviation. Okay, means suppose this is lens and this is the principal axis, this optical center. Okay, so the ray passing through optical center, this like this. Then this ray emerges from the lens without any deviation. मीन्स बिना अपने पाथ से ये विचलित हुए डायरेक्ट निकल जाएगी. क्लियर इट. सो दीज आर 3 रूल्स. So by the help of these rules we form image by the lenses. Okay, now firstly for convex lens, so for image formation we take some different situations of a object. Okay, so first situation is when object is placed at infinite. Okay, so for this we have a convex lens. This is convex lens and this is the principal axis. Okay, this is optical center O. Clear it. When object is placed at infinity, then the rays coming from the object parallel to each other. Clear है. मीन्स जब भी ऑब्जेक्ट इन्फिनिटी पे होगा या इन्फिनिटी पे इमेज बनेगी, देन आने वाली लाइट रेज एंड जाने वाली लाइट रेज, रिफ्लेक्टेड रेज ऑलवेज पैरेलल टू ईच अदर होंगे. क्लियर इट. एंड वन इंपॉर्टेंट थिंग इज जो रेज हैं वो रेज के लिए अपने पास 3 रूल्स फॉलो हुए हैं. तो 3 के अलावा आप कहीं से भी उनको पासिंग नहीं करवाएंगे. फर्स्ट, या तो वो पैरेलल टू प्रिंसिपल एक्सिस, सेकंड passing through the focus point, and third is passing through the optical point. First situation में दोनों parallel to each other. Then in this situation one ray is passing through optical center and other ray is passing through first focus point. Okay, in each situation one ray is passing through the optical center. This thing is remember. Okay, so first condition में suppose this is focus point f1 and this is 2f1. So one ray is passing through the optical center. Then after the reflection this ray is going to own path without deviation like this. एक तो इस टाइप से होगी. क्लियर इट. सेकेंड इसके पैरेलल होगी देन उस कंडीशन में, और वो कहां से आ रही है, फर्स्ट फोकस पॉइंट f1 से पास करेगी इस टाइप से. ठीक है. देन ये जब इंसिडेंट होगी आफ्टर द रिफ्लेक्शन क्या होगा, आफ्टर द रिफ्लेक्शन ये है पैरेलल टू प्रिंसिपल एक्सिस होगी. क्या होगी, पैरेलल टू प्रिंसिपल एक्सिस लाइक दिस. हियर दिस इज सेकंड फोकस पॉइंट f2 एंड दिस इज 2f2. देन ये इमेज दोनों कहां इंटरसेक्ट करेंगी, f2 पॉइंट पे. मीन्स यहां पे इमेज बनेगी. क्लियर है. दिस इमेज आई. सो व्हेन ऑब्जेक्ट इज प्लेस्ड एट इंफिनिटी देन इमेज इज फॉर्म्ड एट ए फोकस पॉइंट f2, सेकंड फोकस पॉइंट f2, एंड विच इज नेचर ऑफ, व्हाट इज द नेचर ऑफ इमेज, विच इज रियल. ओके, मीन्स एक्चुअल में आप इंटरसेक्ट कर रहे हैं तो देन ये क्या होगी, रियल होगी. रियल के साथ में क्या होगी, इन्वर्टेड. क्या होगी, इन्वर्टेड. एंड साइज क्या होगी, पॉइंट साइज. देन इन दिस सिचुएशन m magnification is less than 1 because of we know that if a image is less than to size of a object then m less than 1, but here image is very less than, size of image is very less than, then in this situation m is less than 1. Okay, clear it. Now we take second condition of object, second situation of object, when the object is placed between, second is when the object is placed between infinity and 2f1. Okay, now in this situation again we take a convex lens. suppose this is a convex lens and this is principal axis of this lens. This is optical center O. Okay, this is f1, this is 2f1, this is f2 and 2f2. so here object is placed which is AB. so एक ray तो always passing through the optical center and in next conditions another ray is parallel to principal axis. so एक तो इस टाइप से जाएगी आपके पास में और another one is passing through the optical center like this. okay, this is a second ray. so optical center पे जो रे इंसिडेंट होगी वो बिना किसी डेविएशन के पासिंग हो जाएगी एंड जो पैरेलल टू क्या है, पैरेलल टू प्रिंसिपल एक्सिस, आफ्टर द रिफ्रैक्शन दिस रे बिकम्स दिस रे goes through the second focus point f2 like this, and these refracted ray intersect at this point and this point between f2 and 2f2 means यहाँ पे इमेज बनेगी. when the object is placed between infinity and 2f2 image is formed between f2 and 2f2. okay, clear it. so image is formed between f2 and 2f2 and the nature of image is real inverted and in the size small size. then in this situation m less than 1. clear it. this is our second condition. Third condition is when the object is placed at 2f1 means at this point. आपको एक चीज यहाँ पे क्लियर रखने की, जैसे जैसे आपके पास में ऑब्जेक्ट है लेंस के करीब आएगा देन उस कंडीशन में जो इमेज है वो लेंस से दूर जाएगी. फर्स्ट में इन्फिनिटी देन f2, फिर नेक्स्ट में इन्फिनिटी और 2f1 के बीच देन f2 एंड 2f2. तो नेक्स्ट कंडीशन है 2f1 पे, तो आपको याद होगा आगे अपन अभी इसको फॉर्म करें. देन फॉर दिस सपोज वी हैव ए कॉन्वेक्स लेंस, this is convex lens and this is principal axis, this is optical center f1 to f1, f2 to f2. okay, suppose this is the object is पहले से 2f. so एक रे तो होगी parallel to principal axis and second होगी optical center, pass through the optical center and which is passing directly without any deviation. okay, this जो पैरेलल टू प्रिंसिपल एक्सिस होगी वो कहां से जाएगी रिफ्रैक्शन के बाद में हो जाएगी सेकंड फोकस पॉइंट f2 से. देन इसको पास करवा दो सेकंड फोकस पॉइंट f2 से. देन इन दिस सिचुएशन these refracted rays intersect at this point. okay, and this point is 2f2. so this image is a dash b dash. okay, so if the object is placed at 2f1 then image is formed at 2f2. okay, and the nature of image is real inverted and the same size of the object. in this situation magnification m is equals to 1. clear it. so आज अपन ये तीन सिचुएशन पढ़ते हैं. क्लियर है. नेक्स्ट क्लास में अपन इसकी जो रिमेनिंग सिचुएशंस हैं उनको स्टडी करेंगे. clear. so carefully learn it. these are very important for our competition and for our annual examination. okay students, so carefully study these topics. okay, and if you like the video then like it, share it, subscribe the channel. okay, thank you.